The purpose of this short lecture is to explain some stress design terminologies in terms of safety factors. So the couple of things that we have to keep in mind. First of all, in the general sense, let's suppose you have a load, you have a stress, right? That's multiplied by your design, you have a stress that's multiplied by some of your design factor. Okay, so, and this is maybe some loads, whatever it can be, because of P over A, it may be MC over I, it may be TR over J, or the way we show this was Z and Q, depending on what type of stress this is, right? If this is this, then it will be tau. But let's suppose you got that stress. And for this case, if you're looking at, we know that for fact, this has to be, this is compared to some yield strength, right? And the question we have often is a couple of questions. What do we have here? So if this is less than, if this is stress is less than yield, we know this is safe. If this is equal to yield, this is at onset of failure. It is still safe, by the way, it's just at onset of failure, and be bigger than this, then this has failed. Okay, so if we are now in a case that we are looking to find, maybe we are talking in terms of loads or dimensions, and we say we want to load, if you want to load, if we want a dimensional load required to initiate failure. Okay, so when we talk about initial failure, you immediately know your sigma has to equal to sigma yield. Okay, because it's an onset of failure. That's what it's talking about. This is onset of failure. If it's talking about to resist, right? You want to resist failure. So when he talks about resistance to failure, what he's saying is you want to make sure it does not fail. So we know it's not going to fail if it's less than sigma yield, and it's not going to fail because it's equal to sigma yield, right? Because the terminology that we are using here is you're just going from point A less than to point C, right? So at this point, point is included. It's saying anything in the micro load or any other dimension that would take my point on the left right hand side, it will make it not safe. Okay. And if I'm talking about a case in which you want to design for absolute safety, right? So you want to ensure that you actually have not even started the onset of failure. So this will remain less than sigma yield, okay? And so if I'm going to design for failure, then it's bigger than sigma yield, obviously, right? So, and this concept will apply to everything. This concept can apply to anything, can apply to fatigue, fatigue analysis, can apply to buckling, stability analysis, can apply to strength analysis, a fracture mechanics, fracture analysis, any other analysis. What's going to change is what your loads you're using, right? So let's say in the case of buckling, then you're comparing your sigma with your sigma critical. That's what you're doing. Or you're comparing P versus P critical. This is if you're working in buckling. If you're working in fracture, then for the case of, this is sigma yield, this is sigma critical or P critical. And if you're working in fracture, you work for KIC or you work with KC, depending on the case they're working with. So these are some design criteria that you keep in mind when you're doing stress analysis.